So for this kind of problem, we have to go and look at what we had studied previously. So previously we studied proportions. Okay, now we said that a proportion is written like this, say 1 to 2, could be written to, say, this, 1/2, right? And we knew that when we had proportions, we could have equivalent proportions, right? So equivalent meaning the same. Okay, now if we had an equivalent proportion, I could have 1 to 2 is equal to, say, 3 to 6. And how would we check if these things were equivalent? Here's what we would do. We would take a look at this first part here, and we'd say, what do I have to do to take 2 and bring it up to 3? We're going to have to actually use multiplication, so we're going to have to multiply it by 3. Now, for the second portion of our proportion, what we have to do is we have to say, all right, does 2 times 3 give 6? If this is the case, boom, these are equivalent. Or we could literally say that these things are proportional. And that is another word where we could use to describe the relationship between those two proportions. So now imagine that we were looking at the proportion of shapes. So is there a way to say, look and see if two rectangles are proportional? Let's check that out. So here's an example. So imagine, let's go back to our original problem. Imagine that instead of 1 to 2, we had a length of 1 for our smaller triangle and our width of our rectangle to be 2. And on the big rectangle, I had a length of 3 and a width of 6. So let's draw that. So this would be 3, and then this would be 6. And then this teeny tiny one would have a 1 and a 2. So here is what we would do. We would check to see if the smaller side of my rectangle, doesn't matter the orientation, we try to figure out a number that if I multiply 1 by, I get the next number. So in this case, I multiply 1 by 3 to get 3, right? So 1 times 3 gives 3. And that would say, all right, so that checks out. Let's go and take a look at the second side of our rectangle. And we're trying to match the bigger side of the rectangle to that. Now let's try again. So we go again. So we go 2 times something. So let's check. Let's check if 3 works. 2 times 3. All right. So we go, okay, 2 times 3 gives 6. Hey! So guess what? The lengths and the widths are proportional. So the shapes are proportional. The lengths and widths are proportional. Proportional. So the shapes are proportional. Let's call it the rectangles are proportional. And guess what? That's it. The key is to find a number that links the two sides. If you don't find something that works, then you say, since the numbers don't work, then it's not proportional. So let's go and take a look at an example where it doesn't work. So now imagine I have two shapes for which it doesn't work. All right, so let's go and take a look at this big rectangle here and this teeny tiny rectangle here. So The big rectangle has a 3 to 5, and I have a 1 to 2. All right, so now here's what I would do. I would say, all right, let's see if I can find a number that multiplies from 1 to 3. So I'd go, all right, 1 to 3 is 3, right? If these two sides were proportional, then if this rectangle was proportional, then what we would have is this. Going from 2 to 5, if I actually took the number 3 and multiplied 2 times 3, it gives us 5, then it would work. But you punch it in your calculator, it doesn't work. Es no bueno. It's not good. So you would say, so these rectangles aren't proportional. Now, the reason why they aren't proportional is because if you think about it, there's no number that matches for both of them that I can say multiply, say, one of the sides by to get the same number. So we tried 3. We said 3 worked, but then we tried it on the other side and it didn't work. So guess what? We're done. Okay.